Hi, this is Robert Rcygan. This is for ISA4220 for Professor Green. This is the vulnerability assessment of a Linux and Windows server. First, we'll talk about the method of what we did here to do a vulnerability scan on these servers. I scanned a Windows server that was assessed was found on 192.168.6.14. I ran another vulnerability scan that was assessed, was found on 192.168.6.15, and the vulnerability server was that I used was on 192.168.6.205. The software that we did use to scan these servers was Nessus. We used an advanced scan and certain plugins to basically do a full scan of both systems to see what critical and high and medium and low vulnerabilities were in both of these systems. So as you can see here with our diagram on the left here, we have a severity scale that Nessus uses. It's critical, high, medium, low, and informational. Critical vulnerabilities that are found that are critical should be dealt with immediately and before a machine goes into production. Also, critical vulnerabilities have a CVSS rating of 10. Then next we have high, which vulnerabilities here are ranked as priority as high and has a CVS rating of anywhere between 7 and 9. Would recommend fixing all high ranked problems before placing a machine in production. Medium vulnerabilities here are found ranked as medium and have a CVS rating of 4 to 6. Would recommend fixing all medium ranked vulnerabilities before placing a machine in production, but it's not as critical. Obviously, whenever you're placing a machine into production, you're picking and choosing how much, the amount of risk you want to take with these vulnerabilities on them. For me personally, I would not put a machine in production with any vulnerabilities from medium up to critical. The only one I would do would be low or informational. At that point, would put a machine into production. As we have the next one is low and informational. Vulnerabilities here rank as low or informational, have a CVS rating of 1 to 3 for low. Really, informational is from 0 to 1, but I just put that in there considering that they're pretty much chunked on as 1. These ratings are very low risk for security problems and people infiltrating those security risks. So you could put this machine into production with low and informational only, and over to, if you have the time, just to slowly get rid of those to make sure that pretty much all there is informational and you don't have any levels from low to critical on the machine. Okay, these are some of the Linux problems I found, some vulnerabilities on this Linux server. The first two here, SSL certificate can't be trusted, and the SSL self-signed certificate. These two vulnerabilities are pretty much come down to the person setting up their own SSL certificate locally from the Linux box instead of purchasing one from the certificate authority. So that's why Nessus can't verify this certificate and is hence not trusted. So I would recommend purchasing a trusted and verified SSL certificate from the certificate authority. And then, of course, after purchasing the certificate, you copy and paste them in place of the self-assigned certificates that you created on the Linux box. Should take care of both of these problems for you. The next issue I found was SSL medium cipher suite support vulnerability. Nessus is just stating that that they used a very weak cipher to protect her data or his data from being seen or exploited. Using such a weak cipher can make you vulnerable to a man-in-the-middle attack. So recommendations would be to not use such a weak cipher and maybe use a bigger cipher over 112-bit, or you can always use 3DES encryption. Would recommend the SSL configurations change the cipher that you are using to a stronger one. The next one I found was the SSL 64-bit block size cipher suite support, or suite 32. Pretty much when it comes down to this one here is using a 64-bit cipher is a very weak form of security when trying to secure the information that you're sending and receiving. A hacker or a malicious user can sniff these packets you are sending. Then an unauthorized user they can start sending dummy packets until one of his keys matches yours. After that, he can pretty much decrypt all the data that you send at that point in time, because now his key matches yours and he can decrypt all the data and all your personal information. So I'd recommend that you use a stronger cipher instead of a 64-bit cipher. You can also limit the requests accepted over a secure connection you are working on. The best way to secure this vulnerability is to edit the SSL config file and make sure SSL version 2 and SSL version 3 are disabled. What we have here is we have Windows issues found. When we did a Nessus scan on the Windows server, we came up with these vulnerabilities. As you can see, the first two, SSL certificate can't be trusted, and the SSL self-assigned certificate, same as the Linux box. They went ahead and made a self-assigned SSL certificate through Windows instead of getting one from the certificate authority. So Nessus can't verify the certificate to be an authenticated authentic certificate. That's why it's coming up with these errors. Would recommend the same thing as before. Would recommend purchasing a trusted and verified SSL certificate from the certificate authority, and after purchasing it, basically copying it in place of the self-assigned certificate that was created in the Windows system. Next, we have a DNS server catch snooping remote information disclosure. Basically, in the DNS settings, this allows a response with DNS records from the catch. The problem with this is that if a malicious user does a query of the DNS server, it can see what site you have visited, and if you are the owner of the DNS server, this could possibly give them valuable information like banks you visited, provided with possible user information, anything that they can use to exploit you. So recommendations on that would be changing your DNS settings to stop this from happening. Under the DNS recursion, make sure you check that only for the following client IP address and for everyone, and not for everyone. Also, I would recommend changing your lame DNS request to respond with a refused error message. So if somebody tries to do a query, it's going to refuse that request. Next we have down here is the SSL certificate signed using a weak hash algorithm. Basically, the certificate that she's using here, or he's using here, has a weak algorithm to secure the information she's sending and receiving. If a malicious user wanted to, they can create a certificate with the same signature and pretend they're the service that you wanted to connect to and that you can confide in them. At that point, they can pretty much get any personal information that you're sending and receiving at that point in time, and you just make yourself vulnerable at that point. So recommendations of this would definitely be, instead of creating your own SSL certificate, I would buy one from the certificate authority. They would make sure that you have a good certificate with a strong security and or hash algorithm connected to that certificate.